Thank you for inviting me to present my paper, A Carbon Conservation Core to Restore Forests with Biochar Using Flame Cap Kilns, here at the ASABE annual meeting. Here's the paper outline. The paper covers forest health, fire fuels and climate impacts, flame carbonization technologies using flame cap kilns and other alternatives, comparative life cycle analysis between these different technologies, a look at economic analysis, a look at how we estimate biochar carbon sequestration in the field, the concept of a carbon conservation core and how important it could be to accomplish our objectives, a bit about operational logistics, and critical knowledge gaps and future work. Let's start with what's happening in our forests. We're looking at drastic changes in forest structure and vegetation, especially as we move forward into the climate regime that we're now looking at. And we need to plan. We need to plan to do our best to adapt to these new conditions and to help our forests be as resilient as they can be so they can continue to provide the critical ecosystem services and carbon sequestration that they provide. Here's an example of a project that we did. This was in Oregon, where oak savannas are being encroached upon by small firs and pines. Generally, these are removed and piled and burned for disposal, but in this case, instead, we made charcoal using our biochar kilns. The biochar was then applied in the oak woodland forest to help restore the soils and improve the health of the forest. Here's the problem with standard pile burning, where these jackpot piles are constructed in such a way that they will burn hot and complete ash. There's some really negative impacts. Not only do they generate smoke, but they also destroy the soil organic horizon in these little spots in the forest. We started by looking at the alternative that we called a conservation burn, where first of all we light piles on top. This helps reduce smoke emissions. Then at the end of the burn, instead of letting it burn to ash, we put it out with water while it's still in that glowing coal stage. So we make a little bit of char. Well, what does that look like a year later? These are piles of char that were left behind in these conservation burn piles, and all these things are thriving there. So clearly we've done something better than just burning up the soil. We've left char on the ground, and these plants and fungi seem to be doing well. And that's actually no surprise, because natural biochar from natural wildfires is an existing component of forest soils. These fire-adapted forests, up to 50% of the carbon in these soils is charcoal. So we could make small piles of char by changing our pile burning practices, but we wanted to make more. We wanted to maximize the amount of carbon we could sequester in biochar. So we started looking at kilns. And this flame cap kiln idea comes from these Japanese charcoal kilns. And the way they work is that all the air comes from the top, so they're closed on the bottom. And when you build a fire inside one of these containers, the air comes from the top, the flame burns up all the smoke, and the char accumulates because there's no air getting in the bottom. So you can make a lot more char using this kind of container. Here's the first kiln that I manufactured. It's called the Oregon Kiln because it was designed for our conditions in forests in Oregon. It's robust, but it was heavy, so not easy to move around. But it made about a cubic yard of biochar in 4 hours. Since then, I've now turned to manufacturing and selling this kiln called the Ring of Fire Kiln. It's much more mobile. It's made from 3 panels that bolt together, so it's more user-friendly in a lot of ways. The heat shield improves the efficiency greatly, so it's about 1.5 times as efficient as the Oregon Kiln. This picture shows how clean it is as well, because with more heat retained, it burns the smoke. And in this case, you can see the smoke getting sucked back into the kiln and burned. So it's very, very clean. It's interesting to compare the greenhouse gas impacts or the carbon footprint of this very simple device with a more complex gasifier. In this life cycle assessment, I got to contribute to from the Waste to Wisdom project. You can see that the Oregon Kiln had a lower carbon footprint than the gasifier, and that's just because of the simplicity of it. It's not using all these other ancillary systems that require power. Well, what about the cost? We may be doing a lot better than some alternatives on greenhouse gas impacts, but when you compare what we're already doing, now with the cut, pile, and burn, it's already expensive, but it's necessary because we need to do these fuel load reduction projects. However, there are considerable externalities from them, including smoke and soil destruction. So even though biochar treatments will cost more, we need to look at all of the benefits that we'd be getting. Here's a recent project that illustrates some of these benefits. This is the Usal Redwood Forest in Northern California. It's owned by the Redwood Forest Foundation Incorporated, and they've been working really hard to restore this degraded redwood forest by removing encroaching tan oaks and other species. They've been working with a California Conservation Corps crew, and went to do a training day there in December with the Ring of Fire kilns. This is at the end of the training day, the biochar that the crew made. And they went on to work during the winter, a total of 4 days doing biochar production, and made a total of 57 cubic yards of biochar. There's a lot more to know about that project. It's very interesting. I encourage you to go check out the webinar on the project at the rffi.org website. Here's the production steps, the logistics. You can see there's a water tank that's needed. The kilns are assembled on site, and there's a 4-step process then. The first step is to load it and light an initial charge. When that burns down, then more material is loaded in. So it's several hours of continually loading material into the kiln. Then once it's full, the kiln is taken apart and unloaded and then quenched. And it's quenched by spraying water from the water truck and raking it thin. We found it's really important to have some simple metrics for estimating the greenhouse gas impact of what we're doing. And it turns out, because of the geometry of the Ring of Fire kiln, the 6-foot diameter, a 1 foot of biochar in the kiln is equal to a cubic yard of biochar. And then looking at the bulk density of biochar, we can estimate the CO2 sequestered by using a simple rule of thumb that 1 ton of biochar is equivalent to 2.5 tons of sequestered CO2. This is really important data to have for the future when we'll be getting, hopefully, funding from carbon sequestration credits. And it's also really important just to know for motivation, to know that we're sequestering carbon when we do all this work. And so what are we going to do with the carbon, with the charcoal? We're going to use it in the Usal forest. They're going to be using it, some of it at least, for tree planting. So their goal is to regenerate the redwoods and these poor soils, very impacted soils, are hurting the tree seedling survival. So there's really a great hope that biochar will help with that. So now I'd like to talk about the Carbon Conservation Corps idea. So there are many of these at the state level, CCCs. They might be called Climate Conservation Corps, or Carbon Conservation Corps, or Civilian Conservation Corps. And they're very important because they provide a service year for young people. And the work that they could do making biochar would really make a huge difference in improving forest health and sequestering carbon. But there are other benefits as well to the workers, and these are social benefits. So they gain physical fitness, they learn teamwork, they get job skills that will carry them throughout their lives. And also, by doing this work, actually addressing climate change, this big, huge problem when you think about the youth of today and what they're facing in their future, to know that they've done something, to know that they can do something to address climate change, I think is really important and might be actually even one of the most important results of this kind of program. So in order to make this happen, this work is huge. The landscape that needs to be addressed is huge. It's going to take a huge workforce, and it's very large scale. So what do we need to do to actually make this happen? Well, first of all, we need some pilot projects with good data collection to actually establish costs and benefits. We need to do emissions testings of kilns. We need to do ecological impact analysis. Does biochar really help tree seedling survival? We need to start advocating for the funding that's going to be needed to establish these programs. And once they're established, there'll be a lot of work to do with workforce recruitment and training. I'd like to close by acknowledging all the people that have worked with me over the last 10 years to develop these ideas and to do demonstration projects. There are many, many, many agencies, federal agencies, organizations, community groups, universities, state agencies, watershed councils, so many different groups, and hundreds of small woodland owners, farmers, and biochar enthusiasts who've come to my workshops and demonstrations and helped do the work of throwing that wood into the kilns and making biochar. Thank you all very, very much. And thank you again for asking me to present this work here at ASABE.